Let's look at comparing rational numbers. So first off, what is a rational number? So a rational number is any number that can be written as a fraction. So that includes terminating and repeating decimals. Steps to comparing two rational numbers. First, we are going to look at numbers and ask ourselves, are the signs different? Positive versus negative. So let's look at number one. When I look at this, I see that 4 is a positive number, negative 8 is a negative number. So for the work, all I'm going to use to prove it is I'm going to write a plus for 4 because 4 is positive, a minus for 8 because 8 is negative. So what we should know is a positive number is always going to be greater than a negative number. And remember, we have left is less than, which is this inequality sign, right is greater than, which is this inequality sign. So 4 is greater than is this. Greater than, turn to the right. Negative 12 and 50. So negative 12 is negative, 50 is positive. So we've got a negative and we have a positive. We remember that a negative number is always less than a positive. So left means less than, which is that inequality sign. Number 3. Negative 3.35 is negative, positive 3.25 is positive, so we have a negative and a positive. A negative number is always less than a positive. Left means less than, angled is this inequality sign. And the fractions, again, we don't need to know anything about these fractions, what their decimal equivalents are, or anything. I just need to note that 5/8 is positive, negative 7/12 is negative. So we have a positive compared to a negative. A positive is always greater than a negative. Positive, greater is on the right side. If we angle our inequality sign, it looks like this. So that's when you have two that have different signs. Let's look at some that they have the same signs. They're both negative or they're both positive, but they have different whole numbers. So looking at number 5, I have 2 negatives, so I can't use that. But what I can look at is that the whole number is different. We've got negative 5, we've got negative 3. So those numbers are different. I don't even need to look at the decimal part. I am basically just comparing negative 5 to negative 3. That's what I'm going to put for my work. Remember, if it was positives, 5 would be bigger than 3, but it's negative, so negative 5 is less than negative 3. Bigger negative is a smaller number. Less than is this inequality symbol. Number 6, 2 and 5/6, and then 3/12. So they're both positive. We can't use that. The whole number here is 2. There's no whole number here, which means it is 0. Whoops. So we are comparing 2 to 0. A positive whole number is always going to be greater than 0. Having $2 is greater than having $0. Greater than is on the right. It is this inequality symbol. Now let's look at some where they don't have different signs or they don't have different whole numbers. We have to actually look at what comes after those decimal values. So what we're going to do is that if the signs and or the whole numbers are the same, we're going to turn every number into a decimal to make it easier. We will add zeros if necessary to the right of the last digit so there are the same number of decimal places in each number. And then we compare the number after the decimal point. So looking at this, compare 0.3 with the line over it and 0.3. So they're both positive, they have the same whole number. We need to look at the decimal. It looks like they're equivalent, but remember this line over the 3 means that it repeats. So if I add another decimal value, it would be a 3 because it's 0.3 repeating. Versus for the 0.3 without the line, if I add another decimal value, it's just 0. So when we are comparing, all that we need to look at is what comes after. We are looking at what comes after the decimal point. So we are comparing 33 to 30. So 33 is bigger than 30. It's greater than 30, which is this inequality symbol. All right, both negatives, both have -2 as their whole number. Let's compare by looking at the decimals. So we are just going to be looking to the right of the decimal. We've got -2.73 has 2 decimal values. -2.7 only has 1. So I'm going to add a 0 so that they both have 2 values. So now I'm just looking at 73 and 70. If they were positive, 73 is bigger than 70. But since it's negative, it works the reverse way. A bigger negative is a smaller number. So -73 would be less than -70. Less than is on the left, which is this inequality symbol. Number 7, we've got a fraction and we've got a decimal. So what I want to do when we have this situation is I'm going to make them both into decimals. So 3/4, maybe you know it off the top of the head, off the top of your head. Maybe you're going to use your chart that shows you, or you can plug it in. 3 divided by 4 gives me 0.75 as my decimal. So we've got 0.75 compared to 0.7. When we are looking here, we've got 2 decimal values, we've got 1. So what I need to do is I need to add a 0 over here so that they both have 2 values to the right of their decimal. 75 compared to 70 is bigger, so 75 is greater than 70, or 0.7. Greater than is this inequality symbol. Number 8, we've got 2 decimals. I'm going to write those down here. The first one only has 1 decimal value. This one has 2. So we want to make it so that they have the same number. I'm going to add a 0 here so they both have 2. Now I am comparing 80 to 87. 80 is less than 87. Less than is on the left, which is this inequality symbol. All right, number 9. Compare -1/4 and -17/100. So I'm going to convert these both to decimals. Since there's no whole number, the whole number is 0, so it's -0 point whatever that fraction is as a decimal. So I can either know it maybe off the top of my head, use my resource packet to help me, or divide. 1 divided by 4 is 0.25. Same thing for 17/100. Divide that is 0.17, 17/100. Makes sense. Now I'm looking at the number to the right of the decimal. They both have 2, so I don't need to add any zeros. I am just comparing. If they were positives, 25 would be bigger than 17. A 25-year-old is older than a 17-year-old, but it's negatives. So -25 is less than. A bigger negative is a smaller number. Less than is on the left, which is this inequality symbol. Number 10, comparing -6.05 to -6.5. We want to make them both decimals. So I'm going to rewrite this first decimal. And then the whole number is -6. We're going to figure out what the decimal is by 1/2. Maybe you know that off the top of your head. If not, divide. 1 divided by 2 is 0.5. So I'm not putting a 0 in here because that's if there was no whole number, but our whole number is -6. This first one has 2 decimal values. The second one only has 1. So I'm going to add a 0 so they both have 2. 5 compared to 50. 5 normally would be less than if they were positive. 5-year-old is younger than a 50-year-old, but it's negative. It works the opposite way. So negative 6.05 is actually greater than negative 6.5.